So let's talk about writing Solana programs, and we will see exactly, what I'm kind of talking about here in an on-chain sense. Program ID is the subroutine, and instruction data is the arguments. No, program ID is, I guess, if you can think of like a two-tier subroutine. So instruction data is going to have both the subroutine and the arguments. And then the program ID is like routine, or like the thing that it's going to, like the program that you're using. I'll show you exactly what I mean right now. So in a program, when you write this in Rust, before I get into this, I want to share with you guys one more time the Solana Playground IDE. And this is going to be an IDE that you can use online to write Rust code and Solana programs. So if you don't have any of that installed, you can use this. I'm going to use it in this demo really quickly. So I'm going to use native Rust. I'm going to call this Crash Course. I'm going to create a new project. And then what I'm going to do, and this is just a bunch of boilerplate that the IDE will generate for you. I'm going to click this GitHub icon. And you can see that it tells you how to import for the different frameworks that you're using. And we'll talk about these frameworks at the end. I'm just going to talk about native today. What you want to do is we're going to cover the hello world example right now for the Rust code. So if you go to hello world and you go to program, which I'm going to pull that up on screen real quick. So if you go in here, you can see that there's the tests, there's some other files, and then there's program. And right here is the root of a cargo crate, or your Rust code, right? This is your root whenever you see cargo toml and src. And this is the URL that you're going to want to pass to the Solana Playground right here. You're going to have to hit import. And when you do that, it'll give you your Rust code. It'll pull it right from my GitHub repo. So go ahead and do that if you want. This is beta.solpg.io. I shared the link. The only thing you want to do is you want to make sure that you connect a wallet, hook it up to DevNet. I believe you can do LocalNet, if I'm not mistaken. Let me just see how I can do that here. I think you can. Yeah. So there we go. We're hooked into localhost, which is cool. But you guys can use DevNet if you don't have the local validator. Hopefully those issues are kind of being resolved at the moment. But anyway, so here is the Rust code. And like I have in the presentation slide here, the structure of your program relies on what's called an entry point. And you can see here that entry point is defined with this macro. And for those of you guys who don't know Rust, a macro is basically like an embedded process where you call with this like keyword and exclamation point, and it will build out a bunch of code for you. In this case, what it's going to do is it's going to tell Solana what function in your Rust code is the entry point of your smart contract. And the reason that you need to provide that is because if you look at the entry point we've defined, hello world, these fields exactly match these fields that we saw in a transaction, actually an instruction per se, right? It's the exact same ones. And that's the point, right? Like these instructions go to smart contracts. So your smart contract has to be written to take these in and do stuff with them. And so, like I said, we're going to take a look at exactly how that works right now. So in this case, we're not doing anything special, right? But this is just the general format for writing a Solana program. So I'm going to flip to VS Code so I can show you a little bit more of the repo itself, but feel free to keep following along in the SolPG. So if you look at the program folder, if we look at cargo toml, there's two things that are key. One is we need the Solana program crate, the dependency for using Solana code to write a program. And two is we need to define our Rust crate as a lib, and it needs to be a CDY lib. And that's going to allow us to use the Solana toolkit to turn this Rust code into the proper format so it can be stored as bytes inside of an account, right? So that's what this does. So you need both these things inside cargo toml, and then you're good to go. Flipping back to SolPG, if we take a look here, these are the different things we're going to use to import. And then, like I said, these are the necessary parameters because we're going to be receiving instructions at the smart contract. So Now what we're going to do, just making sure you guys are okay in the chat. Okay. You can see MSG is a macro that's used for printing out log statements. And so in our case, I'm just going to print out hello Solana, and I'm going to also print out our program's ID. Now you can see I'm referencing the program ID parameter, and you might be thinking like, how do you know that this is our program's ID? Well, because an instruction on Solana is designed to send these parameters, if this instruction reaches our program, it's because the Solana runtime said, here's the program ID that was passed in the instruction, and it looked our program up by its address and sent us the instruction. The runtime is only going to send us instructions that are for our program. You can include it here because A, it's part of an instruction payload, and B, you can use it inside your code, right? Like it's a good way to kind of like reference the program's own address inside of itself. So there's an example of how you do that. And then this is what I was talking about reading those accounts. You have to set up an iterator on this list of account info, and then you can go ahead and iterate through that iterator and get all of the accounts. In this case, it's just a pair. So a couple things. One, what's cool about the Solana runtime and building Solana programs is you notice that we, on our smart contract, are getting this account info object. But on our client side, when we sent this instruction, we're actually sending public keys. And you can see that in the like client side code right here. You can see that we're only sending public keys. So what happens is the runtime, because we talked about the whole parallel processing thing and the locking of accounts and stuff like that, the runtime is going to set up all that parallel configurations. And then when the accounts go to reach your smart contract, they're actually being loaded from the blockchain. So they're no longer just an address. They're now the full account info payload. So you get the default fields like the LAN port balance, et cetera, and you get the inner data. So pretty cool stuff. And that's exactly why you see this object instead of pub key. So once you do this, you can actually load that object up into an account info and you can do stuff with it. And you can see here, you can reference the fields. In this case, I'm just referencing the key, but you can also reference the LAN ports, you can reference the data, et cetera. So pretty cool stuff. Now, this is a pretty straightforward program. The next program I'm going to show is where we're going to talk a little bit about the instructions and the processing, some of the things you guys were questioning. But before I do that, I want to demonstrate something that I think is kind of cool. So what you can do is when you're using a local validator, you can just do Solana logs, and that will subscribe to your logs. And since it's just our local one node validator, there's not going to be any logs until we do something. So like, for example, if I go to like our program, spell, I go to hello world, and if I do Solana program deploy, and just by the way, guys, I'm going to demonstrate how you build this thing too. If you're going to, but it takes kind of a while with Rust sometimes. I think I already built this, so it might not take that long. But with Solana, the keyword is cargo build BPF. And in more recent versions of Solana, it's build SBF. But you should be able to use BPF, and it may convert you. Oh, wait, so I got to go to program, sorry. And then you can see that that's going to build. It's going to run cargo build, but it's going to utilize that cdylib config that we provided, and it's going to put it into the right format. And you can find it in the target deploy folder. Here's the key pair for your program's account, and here's your program code. And so what you can do is you can say Solana deploy, Solana program deploy. You can do target deploy program.so. And once I do that, that's going to send a transaction to Solana and tell it to deploy this program. And since we're working locally, you can see there's the logs for it. I was subscribed to these logs, and you can see all the different steps involved in, deploying a program. That's everything that it takes. That's the only thing that this is showing. The tricky part is if you do something like this and you subscribe to DevNet and you do Solana logs, you're going to just get nonstop logs. So a cool feature that you can do, which I'm going to demonstrate on local net just because that's where I deployed my program, is you can do Solana logs and you can grep the name or the address of your program. So if we look at our deploy, it tells us the program ID. And this is just a little bit of like a CLI hack. Like this isn't necessary, guys. It's just if you're working with DevNet and you want to get rid of those logs and you just want to see your logs, this is a really good way to do it. And then I usually just say show like a dozen lines after. So that'll just sit there, subscribe to the logs, and wait for my program ID. And so in the case of my program here, I can just run my test. It's going to go hit my Hello World program. And even though we're local, apparently this is taking a little bit of time. So I'm going to show you guys what this client-side code looks like to hit our custom program. So in our tests folder here, we have this file here. Again, this stuff is the same as we saw previously with the account script. This is just our local pair. And now we're also loading our program, right? So like this is where we saw that key pair. And now here's how you actually create a raw instruction, which I don't know why this is taking so long. Weird. Oh, I know why. I didn't set this to DevNet. Sorry, guys. Really quickly, I'll flip this to local net. Definitely some gotchas along the way that you guys will figure out. But okay, now that that's set to local net, we're still scanning for logs here, and I can go ahead and do our test, which should be much faster. There we go. And then you can see the logs, right? Our program's ID, payer address, etc. So that's a good little trick to read your program's logs. And just talking about the client-side stuff, this is how you create a raw transaction instruction. And then this is a shorthand function for sending a transaction. This is being deprecated, which is why I didn't show you guys this originally. But for testing, you can use it. But I do advise going with the version method that you saw earlier. But right here, you can see that like here's just the same payload that we've been working with for an instruction. So program ID, we've got accounts. For some reason, it's labeled as keys in this object. I don't really know why. And then data. And so again, no data with this example, but this is how you set up a raw instruction to send to your program.